ఇది ఒకటి ఇది ఉంది ఉన్నాయి ఓకే సీమా. So up to now whatever we have discussed in the periodic table, so we are discussing some questions based on that one. Sima, which of the following is a correct statement here? So law of octaves was proposed by Dauberiner. Is it correct? Law of octaves was proposed by Newland. Law of Dauberner's triads name only we have no. So triad rules were discovered identified by Dauber. So both the statements are wrong. So A is wrong, B is wrong. Mendeleev's periodic table is based on atomic numbers. Atomic numbers is wrong. Mendeleev's periodic table is based upon atomic masses. Clear number? So in the original Mendeleev periodic table, elements were classified based on their atomic masses. This statement is correct. Are you able to understand now? So therefore the answer is option D here. Okay. So which of the following statements is not correct about Lothar-Meyer's curve? See the options. Halogens occupy positions on the descending portions of the curve. Alkali metals occupy the maxima of the curve. Clear ma? So alkali metals they occupy the maxima only no ma? So first statement is definitely sorry, second statement is definitely correct. And what are the elements which are present at the base of the Lothar-Meyer's curve? Transition elements. So definitely option C is also correct. Are you able to understand ma? Alkaline earth metals occupy positions at between midpoint and on the descending portions of the curve. Clear now? This option is also correct. Then which is the option? Which is the wrong option now? So option A. So this is the wrong option. So this is my answer. Okay. So option A. Halogens occupy positions on the descending part of the curve is not correct. Where they occupy the ascending part of the curve. This is what we have studied in Lothar's Meyer curve. Clear now? So on the topmost positions are the peaks. At the peaks, which elements we have? Alkali metals, we have sodium, lithium, sodium, potassium, rubidium, cesium, and francium. Okay. What is meant by Lothar-Meyer's curve? It is a graph between okay, atomic volume, atomic radius. So definitely, which elements have highest radius? Alkali metals have highest radius. Already we studied. Because if I travel from left side to right side of the periodic table, what happens? Atomic radius decreases. Okay. So definitely alkali metals has the highest. So that is the reason why they occupy the highest positions of the curve. Because on the y-axis we have radius only. Y-axis when elements ఉన్నాయి. On the y-axis we have on y-axis radius is strong. So which one will have highest radius? Alkali metal. So that was the graph which was obtained by Lothar. అర్థమవుతున్నాయి కదా? That's it. Okay, ma. So elements in the same vertical column of the periodic table always have dash. So vertical column means what? Group, family. So in the family, elements, what is the speciality of elements? What is the property possessed by all the elements which are present in a group? Huh? Same? Same subshell. Same subshell. Very good. Still? Huh? Outermost electronic configuration is same. Outermost electronic configuration is same. For example, you see these metals. Okay, ma? So hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Lithium has an outermost electronic configuration of 2s. Sodium has 3s1. Potassium has 4s1. Rubidium has 5s1. This is 6s1. This is 7s1. So outermost electronic configuration is same. Or you can say the elements which are present in the outermost shell, they are same. Okay, Nama? And what are the electrons which are present in the outermost shell called as valence electrons? We call them as valence electrons only. No? So what is my option? So number of valence electrons are same. Number of electrons is wrong. Atomic number is wrong. Complete electronic configuration is also wrong. So my answer is option number B. That is our option. Are you able to understand? Let us go to the next one. The elements on the right side of the periodic table. What are the elements which are present on the right hand side of the periodic table? S block. Namaskaram, yeah. P block are the elements. S, P, in the middle we have D, and F block elements they are separate. Right side means P block elements. No? So P block elements are the elements. So option C should be our answer. Clear? No? So next let us see. Which of the following statements is not correct? Okay. So there are 8 elements in the third period of the periodic table. Correct only, Rama? Because we have studied about magic numbers. So what are the magic numbers? 2, 8, 8, 18, 18, 32 and 30. Clear, Rama? So these are the number of elements present in first period. These are the number of elements present in second period, third period, fourth period, fifth period, sixth period, and so on. Are you able to understand? So there are 8 electrons in the periodic table of the periodic table. So that means 8 electrons. So this is correct. Clear now? So the elements of groups 1, 2, 13, 14, 15, 16 and 17 are known as representative elements. This is also correct only. Okay, ma? What is meant by representative elements? The elements belonging to S block and P block except inert gases. Inert gases also belong to P group, but they are not called as representative elements. Are you able to understand now? It means out of 1, 2, 13, 14, 16, 17 and 18, 18th group you have to remove. Then the remaining elements which are present in S block and P block, they are called as representative elements. That is the meaning of this one now. So definitely second statement is also correct. General electronic configuration N minus 1D, uh, 1 to 10, NS 0, 1 R. So this is the configuration of D block element. That is also correct. So in the D block, S electrons in the S subshell may be present, may not be present. 0 also may be present, 1 also may be present, 2 also may be present. But what about the electrons which are present in D subshell? They start filling from 0 to 10 or 1 to 10. Correct only, no? So why these electrons have S subshell electrons have 1 electron, 2 or 0? That depends on some exceptions are there. No? Some exceptions are there. So copper is an exception. Okay. No? So in some exceptions, you cannot see total electrons which are presented. Yes, subshell. But in D subshell, definitely you have electrons from 1 to 10. Are you able to understand? Let us visit the D block once here. Configuration is not mentioned here. Huh? Configuration is mentioned here. Are you able to see, ma? So see the configuration of yttrium. How much is the configuration of yttrium? 4D1 5s2. Zirconium 4D2 5s2. But niobium 4D4 5s1. Are you able to see? So in S subshell, how many electrons are there? Only 1 electron is present in niobium. Clear number? So therefore, that is the general electronic configuration. Now you see palladium. You see palladium, see what is the outermost electronic configuration of palladium? 4D10. It means there are no electrons which are present in the S subshell. In S subshell, electrons are not at all present. Are you able to understand? So therefore, what is the outermost electronic configuration of D block elements? One N minus 1 D1 to 10. Ns either 1 electron or 2 electrons or 0 electrons also. Clear no? So that statement is also correct. Now what is the fifth one? Seventh period is the only longest period of the periodic table. Is it correct? Sixth period is also longest. Sixth period also has 32 elements. All the 14 lanthanides they are present. Are you able to understand in the third group? So definitely this statement is the wrong statement. Okay. Next, in the fifth period of periodic table, how many elements have one or more 14 electrons? Are you able to understand? In the fifth period, how many elements have more one or more 4f electrons? Can you see? In which period I am saying? Fifth period. In fifth period, how many elements are present? 0. How can you say 0? In fifth period, there is no F electrons first of all. Are you able to understand? 4F subshell starts from where? 4f subshell starts from sixth period. Are you able to understand? 5f electrons will start from seventh period. In fifth period, there are no 4f electrons. According to which principle? According to which principle? According to Aufbau principle. Already we have studied Aufbau principle now. Let us revise once again. Clear number? So 1s. Clear now? Then it is followed by 2s. Then here I have 2p. Then here I have 3s. Then here I have 3p. Then I have 4s. Then followed by 3d. Then followed by 4. Are you able to understand now? Then we write 5s. Then we write 4d. Then I write 5d. Then it is followed by 6s. After 6s, I have 5d, comma 4s. Then starts the 6. Clear no? Then it is followed by 7s. Then it is followed by 6d and 5f. Finally, we have 7. So this is the structure of periodic table. He is asking which period? He is asking fifth period. In fifth period, are there any F electrons? F electrons are not present. That is our answer. Are you able to understand? So to answer this type of questions, total periodic table should be present in your brain. Periodic table to every point, whatever may be the type of question he will ask you, you should be able to answer. Understood, Nama? That's it. So therefore, which question we are doing? So answer for this one is what? Answer for this one is a D. Okay, no? Seventh period. Next one we are doing an answer. C. So there are no elements which have 4f electrons in the fifth period. Are you able to understand now? Now see the seventh question. Which of the following is a wrong statement? All the actinides, they are radioactive, so definitely this is a correct statement. Clear now? Technetium and promethium are synthetic elements. This is also correct statement. Clear now? Okay. So chalcogens and halogens, they are p block elements. So this is also correct one. Clear number? Chalcogens, halogens, nitrogens, all of them they belong to p block elements. That is also correct. So first member of actinide series is actinium. It is wrong. Are you able to understand now? First member of actinium series is thorium. It is not actinium. All the F block, 5F block elements, they are present in the place of actinium. Are you able to understand? It doesn't mean that actinium also belongs to the same. So in some periodic table, they will write actinium also. But in most of the periodic tables, they start from thorium. Are you able to understand? So when this question is given, then you have to say that actinium doesn't belong to 5F series. Okay, ma? It is not an actinium. No, sir. So see here. So this person, what he has given, he has included actinium also. No? Included actinium also in the 5F series. But if you see one more periodic table, here he also has included, this person also has included. But in the textbooks, you will see that actinium is not included in this. Are you able to understand now? So actinium, you should not say that it also belongs to actinides. It doesn't belong to actinides. Okay. So this is my answer. D. Okay, ma? Now see, eighth question. The atomic number of last member of seventh period of extended form of periodic table is 118 only. Are you able to understand? In the seventh period, which is the last element, organism, it belongs to inert gas family. Are you able to understand? So therefore, 118 is the element. Okay. Next. So question number 9. Elements A, B, C, D, and E have the following electronic configuration. So this is the configuration which is given. Once you see the configuration, then what is the question he is asking? Question is that which of among these belong to the same group in the periodic table? So out of these five elements, which two elements belong to the same group? How can you answer? How can you answer? Hmm? Outermost electronic configuration. What is the specialty of elements in a group? They have same outermost electronic configuration. Number of valence electrons which are present in the outermost shell, they are same in a group. So identify such elements. So 3s1, see if there is any 4s1. No, so this is wrong. Clear number? This is wrong. 3s2, 3p1. So 3s2, 3p1. 2s2, 2p1 is there. It means here in the outermost shell, how many electrons are there? 3 electrons. Here also in the outermost shell, how many electrons are there? 3 electrons. So definitely P and D, they belong to the same P. Are you able to understand now? So 1s2, 2s2, 2p1. That is the electronic configuration of boron. Clear number? And 10 and 30, that is the configuration of aluminum. Are you able to understand? So therefore, they belong to the same. Clear now? That's it. So what is my answer? B and D is my answer. Clear now? So option B should be our answer. Next is, so the period number in the long form of periodic table is equal to what? In the long form, that is in the modern periodic table, okay ma? Period number indicates what? That is the question. Does it indicate magnetic quantum number? Does it indicate atomic number of any element? Does it indicate azimuthal quantum number? Or does it indicate principal quantum number? Huh? Chapali. Principal quantum number. How can you say principal quantum number? Because period number indicates number of shells. No? Period number indicates number of shells which are present in that particular element. For example, if I say fifth period, it means all the elements which are present in the fifth period, they have same number of shells. That's what we have discussed now. So therefore, option D should be our answer. Option D is our answer. Clear number? Next, let us match the following list and select the correct answer. So 1s2, 2s2, 2p6, 3s2, 3p6. Outermost configuration is completely filled number. So definitely this belongs to noble gas. Clear no? 1s2, 2s2, 2p6, 3s1. Alkali metal, because outermost electronic configuration of alkali metal is 3s1. 3s2, alkaline earth metal. 2p5, halogen. That's it. Are you able to understand? According to that, you select your answer. So A is the answer which you give. Clear now? Next is. So there are 4 D block series. In D block, how many series we have? 4. Let us see the periodic table once again. Where is the periodic table? So these are the 4 series, Rama. So this is our first series, second series, third series, and fourth series. All of them they are called as D block series. Able to understand? So therefore, 10 folds are 40 elements are present. Now let us go to our question. Okay, ma? So there are 4 D block series. Is it correct? Definitely correct. So first option is correct. And total D block elements are how many? 40. That is also correct. D block series starts with the lanthanum and ends with mercury. Is it correct, ma? It is not correct. D block series doesn't starts with lanthanum. D D block series, let us see the fourth option. All D block numbers are metals and sorry. So this option is correct only. Clear now? So in one series, it starts with lanthanum and ends with mercury. Now let us see what is that series. Clear now? So sixth. So it starts with, this is the lanthanum. So it starts with the lanthanum and it ends with mercury. So that is correct. Now let us see what is the fourth statement. Fourth statement is all the D block members are metals and found in nature. Definitely they are metals. All the D block elements definitely they are metals. All S block elements are also metals, but they are not found in nature. That is the problem. All of them they are not found in nature, Mama. Only some of them they are found in the nature. Some are prepared in the laboratories also. Some are synthetic elements also. Clear? No? So therefore, the fourth option is wrong. Therefore, how many statements are correct? First one is correct, second one is correct, third one is also correct. Able to understand now? So option is option C. That is our answer. Now let us see. So an element with atomic number 82 belongs to which group of the long form of the periodic table? Clear, ma? Now see. So how to answer this type of question? Huh? Ah, let us see how to answer this type of question. An element with atomic number 82 belongs to which group of the periodic table? Are you able to understand? Sima, one method of solving this, you have to write all the configuration. How many electrons are there? 82 electrons are there. If you start arranging them in electronic configuration method, total 3 hours will be completed. In total NEET exam, you will be writing configuration. Are you able to understand? So instead of that method, you can do one thing. You can learn the atomic number of alkali metals. You can by heart the atomic number of inert gases. Are you able to understand? And by comparing them, definitely you can say this one will be present where. Are you able to understand? Let us see the method of solving this one. So he is giving atomic number 82 number. Now let us go to periodic table 82. See. So here if I see radon, radon, radon is 86. No? Here if you see radon, radon is 86. So if it is 86, this is 85. Okay, ma? 85, 84, 83, 82. I can identify like this. This belongs to which group? This is group number 18. This one is 17. This one is 16. This one is 15. And this one is 14. So it belongs to which group? 14th group. That's all very simple. Are you able to understand? So which one you have to by heart here? You should have remembered previously that radon has an atomic number of 86. Clear, no? Then you can very easily answer this type of questions. అర్థమవుతుంది కదా? That's it. So what are the two minimum atomic numbers you have to remember? Hydrogen, helium, argon, krypton, xenon, and radon group wise. Clear, no? 2, 10, 18, 36, 54, 86, and 118. Similarly, you have to by heart these also. Lithium, sodium, potassium, rubidium, cesium, and francium. So 3, 11, 19, 37, 55, and 87. Are you able to understand? Now see. This you can manipulate by one more method also. See. So what are the magic numbers we have studied? 2, 8, 8, 18, 18, and 32. And 30. This is what we have studied now. Now you see. So to this one, if you add 2, it will become lithium. Clear, no? Magic numbers we are adding. Magic numbers is nothing but number of elements which are present in that period only. No? That is called magic number. Are you able to understand? No? And to 3, you add the next magic number 8. It will become sodium. Clear, no? And to sodium, you add the next magic number 8. It becomes potassium. Clear, no? To this potassium, you add the next magic number 18. It becomes rubidium. Able to understand? To rubidium, you add the next magic number 18. It becomes cesium. Okay? To cesium, you add the next magic number 32. It becomes correct only, na? It becomes francium. Are you able to understand? No? And in francium, we have again 32 elements. That's it. Clear, Nama? So in this method also, you can identify what is the atomic number of this alkali metals by just remembering the what you call magic numbers also. 2, 8, 18, 32, and 2, 8, 8, 18, 18, and 30. Okay, ma? That's it. So that is the reason why I am making you to by heart this periodic table. Clear? Whatever may be the type of question, you should be able to answer in a very less time. Requires how many electrons for becoming stable? Only one electron it requires. Similarly, if you look at element A, it can lose 2 electrons. No? It can lose 2 electrons to gain the octet configuration, because here I have 2s2 and 2p6. It is an octet configuration. So therefore you write 2 here and you write 1 here. So this 2 you take to the base of B, this 1 you take to the base of A. Therefore, what is the compound which is formed? AB2. So this can be the molecule which can be formed. Are you able to understand, ma? AB2. Or you can explain this one in one more method. See, ma. A can lose how many electrons? A can lose 2 electrons. It means A loses 2 electrons. But B can gain how many electrons? Only 1. It means 2 B atoms are required. How many B atoms are required? 2 B atoms are required, and only 1 atom of A is required to gain a stability. So therefore, A is 1, B is 2. So AB2. This is the molecule which can be formed. Are you able to understand now? Or just you write their valencies here. So 2 and 1. And first one you write to the subscript of second one. Second one you write to the subscript of first one. In this method also you can say what is the type of compound which can be formed. అర్థమవుతుంది కదా? Just a method of cross multiplication. You can replicate. Clear? Now see. Okay, so match column 1 with the column 2 and select the correct answer. So Mendelevium, Seaborgium, Copernicium, and Technetium. It is very tough, ma. Only people who have by hearted only can say this one. So we have to refer to the periodic table, or we can do one more thing. We can refer answer here. Answer is C, 3412. Okay. So what is 3412? A belongs to 3. Mendelevium is 101. And B, Seaborgium, B is 4, 106. Copernicium, C is 1, 112. Technetium should be belonging to 43. Okay. So there is no other option other than by hearting to answer this type of questions. Clear? One not elements by heart quoted on 30 very optional. That's it. Next, let us see the next question. Match column 1 with the column 2 and mark the appropriate choice. S block elements, so they belongs to groups 1 and 2. P block elements, so P block elements 13 to 18. Clear number? D block elements 3 to 12. Clear no? Representative elements, so representative elements are 1, 2, and again 13 to 17. Both S and P block elements except inert gases belongs to representative elements. No? So that should be our answer.